All right, guys, today is the final transformation of this week, and then we'll look at some multiple transformations tomorrow, and then a few more things next week. So today we're looking at dilations, which is going to be the enlargement or the reduction of a figure. The scale factor indicates how much the figure will enlarge or reduce by. The scale factor. The variable k is used for the scale factor, and when k is greater than 1, that will be an enlargement. And when k is less than 1, that is called a reduction. All right, so let's look at a couple problems. Let's just start with number 1. Number 1, k is greater than 1, so this is going to be an enlargement. And for these problems, you just multiply everything by the scale factor. So pretty easy, just know that your pre-image should be smaller than the final image because it's an enlargement. So r prime is going to be negative 10, comma 2. Again, you multiply, we're multiplying everything by 2. So negative 3, comma 4 is enlarged to negative 6, comma positive 8. So I'll just put up here to multiply. That's all you're doing for the scale factor. Last one, t prime, that will become 4, comma negative 2. If we are to graph these, again, graphing helps. It's not necessary, especially if you don't have a printer at home. I don't think we'll do much graphing for your test since it'll be online. But for just the sake of seeing what an enlargement looks like, I'm going to go ahead and graph it for you. Make sure you're labeling as you go. Okay, so this one crosses over into mostly 2 quadrants. So there's our pre-image, and if I graph our final image, it looks like this coordinate plane is counting by 10s this time. They were counting by 8s yesterday. All right, s prime is negative 6. And that's s prime. T prime's 4, negative 2. And there's t prime. So here's our enlargement. It's on the outside of the triangle from before. All right. Let's skip to number 3. That's going to be a reduction. So we're multiplying everything by 1/2, which is the same thing as dividing everything by 2. So j prime is going to be negative 5, comma 1. K prime will be negative 1, comma 4. Dividing by 2, same thing as multiplying by 1/2. If the numbers ever get tricky, you may use a calculator. And here are my new vertices for the rhombus. Number 4, that's going to be a reduction. Divide everything by 4. Does everything divide evenly? It looks like x, if you do divide that by 4, that's going to be 10 over 4, which reduces to 5 over 2. Or if you want to put 2.5, decimals are okay as well. But fractions work good for me. All right, let's flip to the back and let's look at, let me make sure there's no tricky ones on the back here for me to look at before I have you try some. All right, let's look at number 5. Number 5 has a scale factor of 5/2. Is that going to be an enlargement or a reduction? Because typically reductions are fractions, but this is a fraction and it's greater than 1, so this is an enlargement. So just because it's in a fraction doesn't always mean it's going to be a reduction. All right, So for this one, the multiplication obviously for d prime, multiplying times anything is just 0, 0. But when you multiply 5/2 times 2, you multiply the top. 5 times 2 is 10, and then divide by the denominator. So 10 divided by 2 is 5. Or you can use your calculator, or you can do it out to the side. 5/2 times 4 is what we're looking at. That's going to be 5 times 4 is 20, divided by 2 is 10. If you have to write it out, just write it out. All right, multiplying as we go. I know some people last semester had a hard time with this fraction, multiplying fractions. It's been a long time since we've been in school. And then you can plot, just make sure in this case your final image is going to be on the outside of your pre-image because it's an enlargement. All right, let's jump down to, let's look at number 11. All right, number 11, we now have to identify the scale factor. Well, first, let's keep in mind that this is the pre-image. The final image is on the inside with the apostrophes, the D prime, the E prime, the F prime. That indicates it's our final image. So if the final image is smaller than the pre-image, that's going to be a reduction, which tells us that we're going to have a fraction for our scale factor. So what I would do for this one, I would just write down a pre-image point. So let's start with D, 1, 2, 3, 4, 5, 6. So D is going to be 0, 6, and D prime is going to be 0, 2. That one has a 0, so it's hard to tell, but we can look at the 6 and the 2 and compare. Let's do another one, and we'll look at both of them to make sure that they are reduced by the same amount. 1, 2, 3, 4, 5, 6, 1, 2, 3. So for F, we have -6, -3, and then for F prime, -2, -1. So I could have used E and E prime, but we'll start with these two. You don't have to check all three of them. They will always match. All right, so 6, that's going to be scaled down and reduced divided by 3. Let's check the rest. Yep, that works. So your scale factor is 1/3. Again, the final image is the image with the apostrophe, so that's what you'll have to keep in mind. All right, the only other type of problem on the notes for today would be like number 9, and it's actually similar to like number 5, except for you'll want to write down the vertices for number 9. Start by doing that. So Q, you'll want to write down the pre-image, and then even if you don't graph, you can just multiply everything by your K value, and it will be an enlargement. So Q is -1, 4. Then you're going to multiply each one by 3/2. So again, this one multiply the top. 3 times -1 is -3, and then divide by 2. You can just leave that as -3/2. It's not going to reduce nicely. Multiply. 3 times 4 is 12, divided by 2 is 6. And that's your Q prime. Again, I'm not as worried about the graphing, so no need to do that. Go ahead and give these a try. I believe there's an error on number 12, so just skip that one. It looks like they've messed up one of the vertices. Thank you, guys.